This lesson is on rational algebraic expressions, and we're going to be factoring and simplifying expressions that are fractions. So let's start with factoring. So we're going to look for common factors before we try to do the two parentheses binomials. And I see in this fraction, this numerator has a common factor of x. Now remember, factoring is dividing, and so I'm dividing an x out of each term. Like so. And then my denominator is a difference of squares. Now what I'm looking for is a common factor common to the numerator and the denominator, and I see x minus 2. So I'm going to cancel both of those. And then I'm going to write down what's left, which is x times x plus 2. Now before we get too far into this, I'm going to comment on what students are tempted to do. Students a lot of times see the x squared and x squared on top of each other like that and decide to cancel those. Well, you can't do that because you can't cancel terms. You can only cancel factors. So an example that I like to use is I'm going to have 5 plus 2 over 2. So factoring the 2's here, right there, and canceling those is the equivalent of canceling those two x's. Well, let's look at the consequence of that. If you cancel those 2's like that, then you're saying that this number is 5. Or sometimes they go, alright, that's a 1, and they'll say it's actually 6. But actually the number is 7 halves, and that's nowhere near the same. So that's why you can't cancel by term. You can only cancel by factor. So let's look at example 2. So we're going to begin by factoring. My numerator, I see, I have 5a and a, and then I have 1 and 1, and I need to figure out where to put the negative, because this negative here tells me I need one positive, one negative, but I need the positive placed in such a way that my 4 is positive, so I put it there. Alright, so that's my numerator. My denominator, I have a common factor of 5 everywhere, so I'm going to factor out the 5 and say a squared minus 2a minus 3. And this is also factorable. So we're beginning with this problem with the thought that we're going to be canceling, and my numerator is completely factored, so it's going to give me a hint as to what one of my factors could be. And it can't be 5a minus 1, so it must be a plus 1. And the other factor must be a minus 3. Okay, so I do have factors in common, which I will cancel. And then I'm going to write what's left. And leave your answer factored. We're going to have to be in this habit for right now because we will be doing factoring when we are solving problems, and we need to be able to keep that factored. Alright. Last example for this section. Well, it's a multiplication, but what I see is a negative exponent. Well, a negative exponent means a reciprocal, so we're going to move this entire factor to the denominator. Like so. So we now have 2x plus 3's in the denominator. This is already factored, so don't FOIL it. Just leave it alone. So I'm going to factor my numerator, and since we're looking for hints, let's see if something with x plus 3 is going to work. X plus 3x minus 2 works. Clean that up a little bit. There we go. Over x plus 3 squared. So I've got 1x plus 3 in the numerator and 2 in the denominator, so I can cancel this whole one and one of these. And so what I'm left with is x minus 2 over x plus 3. And that's the whole lesson on reducing rational algebraic expressions.